Hey everybody, this is your video on additional review 5 to 8. So on a problem like this, with the cube root of 2/7, what you want to do is multiply by 1 in the form of 2 squared over 2 squared. The reason is because, 2 is the same thing as the cube root of 8. And so we're going to want to make it 2 times 2 squared. So 2 times 2 squared equal 2 cubed, which equals 8. So that's the reason behind it. So when we do that, we have the cube root of 2/7 times 2 squared over 2 squared. Again, if you have the same thing on top and bottom, that's fine. You're multiplying by 1. And if you multiply this straight across, you get 2 times 2 squared is 8. 7 times 2 squared means 7 times 4, which is 28. And then from here, I'm just demonstrating if you have a tall cube root, just like if you have a tall square root, you can break it up. And then the cube root of 8 is 2, and the cube root of 28 cannot be simplified. Last thought about that is on the calculator, if you press this control up arrow button, that's where you're able to type a 3, and then I put an 8 here, and that tells you it's 2. So that's how you do the first one. On a problem like this, what you're going to want to do is multiply every term by x squared, since it's the greatest power in the denominator. And so if you have your 4 over x squared minus 36 over x equal 19, we're multiplying by x squared. So then when you distribute this is just 4, and you distribute it here, it's minus 36x, and then equal 19x squared. Now, since we usually keep our x squared term positive, we need to bring this over. So it'll be 19x squared, and then plus 36x, and then a minus 4. From there, you can factor it if you want to, or you can do it different approaches. Quadratic formula if you want. Quadratic formula, by the way, if you want, is negative b plus or minus the long square root b squared minus 4ac over 2a. Now what I'm going to do is I'm going to factor it though, because if it's something unusual like 19, for 19x squared, I'm going to try to do 19x and x. And now with it being negative 4, that's going to be either 4 times negative 1, or that's going to be 2 times negative 2. So in this case, I'm going to use the 2 and the negative 2. And what happened was I do 19 times 2 is 38. 38 minus 2 is 36. And so that's going to work. So I could either say plus a negative or just rewrite it. It's 19x minus 2 times x plus 2 equals 0. So now because of that, we can set each term equal to 0. So 19x equal 2, and x is 2/19. And x plus 2 is 0, so x is negative 2. So that's how you get that one. That'd probably be hard to just estimate what the decimal is, but if you are using that approach, base it on this number and try 1/19, 2/19, etc. That's if you're going to graph it. So, for example, if you want to take a completely different approach with using your calculator, 4 over x squared minus 36 over x equal 19. I'm going to have to say minus 19. And then you want to go to 19. No. You're going to want to see where it crosses. So you want to analyze graph, intersect. This one. Oh, I forgot to put 0 there. Menu, analyze, intersect. From there to there. That gives you -2, 0, which is what that answer is. Right over here. Now this one, when we do that, we get point, I'm going to write this down over here, 0.105263 and some other stuff. Now, when you think about what possible fraction that would be, you're going to have to base it on that number. Is it 1/19? Is it 2/19? 3/19? Or what? And in this case, it's 2/19. So if I do 2 over 19 as a decimal, I get the 0.105263. So that's how that works. So now on this one, what you're doing to begin with is getting your x-intercepts. And so for your x-intercepts, set your numerator equal to 0. So we have 9 minus 3x squared equals 0, which means 9 equal 3x squared, because we're adding 3x squared to both. Then you're going to divide by 3, and we get x squared is 3. So that means x is plus and minus the square root of 3. And that's what they want for here. So basically, the important part is for your x-intercepts, set your numerator equal to 0. Because if you graph it, on this one you'd get plus and minus 1.73 something. And then you'd have to say square root of 3 as a decimal is 1.73. But your best bet is just set your numerator equal to 0 and solve. Now for your y-intercept, think about what that means. The y-intercept would be like 0 comma a number, like 0 comma b or 0 comma y. And what we do is we set f of x equal to 0. Set x equal to 0. And so if we have 9 minus 3 times 0 squared over 0 squared minus 16, 0 squared is 0, and 0 times anything is 0. So I have a 9, and in my denominator I have -16. So I'll just put -9/16 like that. And again, if you were looking in the table, then you need to change the decimal to the fraction. So let's see what that looks like. For our numerator, we have 9 minus 3x squared And for your denominator, we have x squared minus 16. So there's your x-intercepts. So remember we could have done 0 of the graph earlier, and there's your 1.732. Now for your y-intercept, we see it's negative because it's below the x-axis. And if we go to our table, it's 0, negative 0.5625. Excuse me. 0, negative 0.5625. It's not continuing after that, so it's called a terminating decimal. And so if you wanted to, you could say negative 0.5625 menu number fraction, and that gives you negative 9/16. So that's how you get it. Now, for the vertical asymptotes, those are going to be based on the denominator equal to 0. So if we have x squared minus 16 equals 0, x squared is 16, and x is plus or minus 4. Again, you can get that from looking at it and seeing 4 undefined and negative 4 undefined. Just kind of like eyeballing it. 1, 2, 3, 4. It's approaching positive infinity as x approaches 4 from the left. Y approaches positive infinity, and as x approaches negative 4 from the right, y also approaches positive infinity. So that's just meaning straight up. If y approaches infinity, it's a very high number for these. If x is approaching infinity, that's the far right and the far left. Now for your horizontal asymptote, the easiest way to remember that is we have our 9 minus 3x squared over x squared minus 16. And use your corresponding exponents. In other words, just care about negative 3x squared divided by x squared is negative 3. And that's going to be that answer. Now what you can do again is graph it. Put 3 here. Whoops, I meant not negative 3. That's funny. Negative 3. And on the far right and on the far left, the curve is approaching that. So that's why it's negative 3. And speaking of that, they want to graph it, and that matched the C graph. You'll probably do the graph yourself pretty easily. You see your dashed line and see how it matches. It looks like the main difference between B and C is this is off center and this one's symmetric. To the y-axis. Okay, that's the difference. Okay, on your next one, what you're doing is you're plugging in different numbers to here. And so for the g of 5, you do 5 minus 2 over 5 plus 3. So that's 3/8. And on this one, you're doing 2 minus 2 over 2 plus 3. So that's 0/5, which is 0. On this one, you're doing negative 3 minus 2 over negative 3 plus 3. So that gives you negative 5 over 0, which is undefined. Or it says does not exist. Now, about not a real number. Not a real number means imaginary. In other words, like plus and minus 2i, or you could say the square root of negative 4, for an example. So that's what that would look like. Now, this one, you just have a random decimal. So I'm doing negative 18.25 minus 2 over negative 18.25 plus 3. Don't try canceling anything. The best way is just use your parentheses, divide by parentheses. So that's what we want. Parentheses, negative 18.25 minus 2. That's your compound numerator. And then your compound denominator is negative 18.25 plus 3. And it gives you 1.32786, and so forth. They want you to round to 3 decimal places. So that's 1.32. And then based on this 8, you have to round the 7 up. Could make a drink joke, but I'm not going to. Now, on this one, we have x plus h. So basically, wherever you see x, you put x plus h. So we have x plus h minus 2 and x plus h plus 3. And so then that just drops the parentheses because you're adding, and that's your answer. So the first couple were from number 5. This is from number 6. This one's also from number 6. And this reminds me of what you do, or what you did in chapter 1 of calculus with doing f of x plus h. So we actually did that formula with the limits also. If y'all remember, we did h approaching 0. Okay, so to begin with, all we do is we say f of x plus h is 3 times x plus h minus 6. So that's 3x plus 3h minus 6. Now for this next part, for b, we want to say that answer, 3x plus 3h minus 6, and we want to subtract the function, which means we want to go 3x plus 3h minus 6 minus 3x, so that cancels, and plus 6, because minus and negative is plus, so that cancels. And so then all we're left with is 3h for your answer. Now, we have our numerator done, so here we just do 3h, divide by h, and get 3. So that's how that works. If you remember from a long time ago, for this part, this one part, you could think this answer was the slope of y equal 3x minus 6. So it's just the 3. And then if you work backwards, 3h, and then so forth. Okay, so that was section 6. Now we're on section 7 with some stretches horizontally and vertically and so forth. Now this one actually isn't that bad because for negative 2x minus 3, we just start with the x. So because this is a linear graph, we just start with x. And then the next part is, do we stretch it or shrink it? And so a stretch would be if it's greater than 1. The negative sign, you know what, I'm going to put absolute value. If the absolute value of negative 2x, or absolute value of negative 2 is greater than 1, because 2 greater than 1 is true. In other words, you would put shrink if it's between 0 and 1. But it's stretch if the absolute value is greater than 1. So that's going to be a stretch. So in other words, it's steeper. The next part is it's going to be vertically because it's in front of x. And then the rest of the sentence by multiplying each y coordinate by 2, because, I mean, that's basically what we're doing, and reflect it across the x-axis since it's negative 2x, and then shifting it down 3 because it's a minus 3. So then you have to graph it and check your table to make sure you're going right, or start like with negative 3, like 0, negative 3, and then go down to right 1, and then plot your point. So that's how you do that one. Now this is more transformations on it, and so you're basically starting with whatever they give you. It says reflect across the x-axis, which means the negative in front. And then it says shift it 2 units to the right. Now, the right means use minus. So you'd have negative cube root x minus 2. Then it says down 4, which would be use minus at the end. So that's why it's like this. And then you're going to graph it on your calculator, and it's going to look like that. In a way, it's similar to my wedding ring, because this looks like the cube root of x, and then cube root would be the other way. Well, I can't do that. If it were reflected and then shifted, you know, if it went right 2 and down 4 and reflect, then it'd look like that. Okay, so then on this one, they want you to do F circle G, which means F composite G. So that means you start writing your F function, which is the square root of 2, and instead of x, we have to put 1 over x. So that gives us the square root of 2 over x. So that's your answer. And remember, when it's a square root, the domain is normally on this one, like x greater than or equal to 0, or with a bracket, like 0 infinity. Now here we have to make sure it's defined for g also. Make sure 0 is defined for g of x. And since it's 1 over x, it isn't defined. And so then you got to change the bracket to the parentheses. And so that's why we get 0 infinity. Okay, on our next one, we have 3x minus 5, which is a linear function, and we want to get the inverse. So to do your inverse, we have y equal 3x minus 5, and switch x and y. So x equal 3y minus 5. Then you want to add 5 to both, so x plus 5 equal 3y, and then divide by 3. So then that's your answer. And it is 1 to 1, because linear functions will always be 1 to 1. What I mean by that, just to be completely correct, is if it's an oblique line, like slanted left or right, you know, it will be 1 to 1. Okay, and then they're going to want you to graph both. And so this is the one where it's 3x minus 5. You could probably see on all of them negative 5 is a y-int. And then you want up 3, right 1. Up 3, right 1. And also do your inverse. Looks like all of them may be with this situation. But with this one, you could also graph that. Or think of it as x over 3 plus 5/3, or even 1/3 x plus 5/3. So that's going to have a positive y-intercept, which happens, well, a positive y-intercept and positive slope. Has a positive y-int and positive slope. And so that's going to be this one. So the dashed line has a positive y-intercept. This one has a negative. This one has a positive. But then you want a positive slope. It's slanting up, not down. So slants up. And if it is linear, you're just going to have all real numbers for both of these and for both of these. Okay, and now we're on to lesson 8. On this one, we're doing exponential functions. And what we start with is when you look at the graph, well, they want you to graph it. Let me just break apart what we know. We know this part means right 2, we know this part means up 3, and we know this part means reflect the x-axis. Okay, so let's graph it, and you should end up with that. So we go -3, up arrow, x minus 2, and then plus 3. Okay, so that's that one. Key things in the table you're going to want to look for is 3, 0, if there's any other good ones. It looks like there were several good ones further down, like 2, 2, and 4, -6. So if you need to actually use points to graph it, you can. You might have to say things like, check the part where the box where it says reflect the x-axis. Make sure you translate right 2 and up 3. So when it looks like this, the domain could be all real numbers because x can be anything. And then the y goes as low as you want to this. Now it's continuing to go up after this. No, it's actually stuck at 3. Yeah, it's stuck at 3. This number right here is your, since it's up 3, that is your horizontal asymptote, y = 3. So based on that, you do -infinity to 3. For your y-intercept, remember it's 0, comma a number. And so we'd have to work it all out. So basically we go y = -3, 0 minus 2 plus 3. So this is y = -3 to the -2 power is the same as saying -1/3 squared. And I'm just getting a number. It's like -1/9 plus 3. And so that's 26/9. Because think of this as 27/9. So that's how you get your 26/9. And like we said, the horizontal asymptote is y = 3. Now for this one, you have your your e function, which is about 2.718. So you're going to reflect the x-axis, and you're going to go right 7. Because whenever it's an exponent, then that indicates whether you're going left or right. Now, when we graph it, you'll see, it's going to look like that. And this is going to be all real numbers. Now, in this problem, you have a horizontal asymptote of y = 0. So that's why it stops at 0. And this is directly related to this answer. Now for your y-intercept, that is going to look a little unusual for you, but what you do is you just say y = -e to the 0 minus 7, and then that just simplifies to -e to the -7. So that's why it turns out to be that way, because we just substitute, and put x = 0. Okay, now we have a few on rearranging. So the first thing is you're going to see that this is multiplying 13 times y. And in log language, times means add. And so you're going to have log 7 13 plus log 7 of y. So that's really just a one-step problem. Now on this one, in the log language, divide means subtract. So the first thing is we would say this is ln 3 minus ln 7x to the 7th y. So there's your ln 3 part. Now this part is a product also, and so we have to put a minus and then treat it like separate terms. So you have ln 7 and then based on this exponent, I'm going to say plus ln x to the 7th plus ln y. I'm trying to take steps for you. You might be able to just figure it out. So now we're going to distribute the negative sign. And if you have an exponent up here, it goes in front, kind of like when we were doing the derivative. So the 7 goes in front. And then leave this ln y. And then our last step, let me go ahead and write down these ln 3's. Our last step is distribute the negative sign. So this is minus ln 7 minus 7 ln x minus ln y. And that gives you your answer. Okay, that's all for the review. Hope that helps.